Hello, I'm Steve Rooks, and today I'm going to give you a demonstration of Rhapsody Systems Engineering, and I'm going to show you building the car interior model from scratch. We'll work our way through several of the layers, and then I will switch to a completed model at the end. So this is Rhapsody SE, as we call it. This is the view a user sees. You see the projects which you have been granted access to. And then when you start to make changes to your projects, they'll then move into what's called the active projects view. And this is where your private branch, where you're working on before you deliver your changes to your team. This is where you can see effectively your work. I'm going to create a new project. So let's hit create. Let's call it CIC build 4. I will choose the Harmony template and hit create. So let's go to the project. And you'll see that the project is created a folder structure. Actually, before I just do that, let me just come back to the project and I just show you a couple of things here. So on the project itself, we can manage the users who have access to the project, OSLC associations, to other tools like Doors Next, and we can also create effectively imports to libraries from other projects. So this is how we can start to share information, modeling information, libraries and these sorts of things between different projects. So let's go back. In choosing the Harmony template, it's created for us this model structure. So on the left hand side here, we've got the model browser. So this is our model. We also have a library view. Here we can see libraries which are being pulled in. Some of these are standard SysML libraries. We've also got a Harmony library. I'll just show it here. And within this library, we've defined some new model element types which are useful for the Harmony workflow, such as system actor, trace relationship, and there's some SysML gobbledygook here, which is how we can create our new types in the SysML textual notation. Let's switch back to our project view. Here we can pull in external libraries. So, for example, ISQ base, for example. So here we can pull in one of the SysML v2 libraries, ISQ base, for example. I can click import, and now you'll see, for example, that library appearing in our list here with all the new definitions which are contained in it, which we can now use in our model. Moving from the model browser across, we've got our main drawing surface here, which is where we've got our different types of views. And then again, coming across, we've got our properties view, which we'll see in use. You've got the ability to search in the model, move backwards and forwards. We have a project validator, so that runs some rules. Export project to a JSON format. Here is the information around which version we're working on. So currently we can see we're working on the main branch. A bit later on, when I save the model, you'll see we switch to a private branch. Undo and redo, how we can commit our changes back to the team onto the main branch, and how we can manage here extensions. So these effectively using the client API, we can add in new functionality into the product. I'm going to use the tech preview feature, and I'm going to switch on our Harmony IQ, which is our graphical process framework for supporting Harmony, and also the model to text conversion, which is quite useful. Okay, like so. Let's just check. Okay, so yeah, here we have the textual. So we can have a textual view of our model as we go along, if you want to have a look at that. So first things first, let's just expand the Harmony structure. So this is our FLP, requirements layer, functional layer, logical and physical. In the requirements layer, we are going to import some requirements, define some use cases, build a top level system context. In the functional view, we'll then start to refine things. We'll start to define an action flow view with some behavior and a bit more structural work. And then the logical architecture view, we will define a more detailed system architecture, logical architecture, and we will allocate our system functions onto that architecture using the new SysML Performer capability. Let's go to our process view. So this is Harmony IQ. This effectively is we have our layers here, RFLP down the left hand side, and the different types of activities along the top. And we will start in the top left hand corner, collect stakeholder requirements. So let's initially mark that as started. And you'll see here what it tells us to do. Import or create stakeholder requirements to establish the requirements baseline. And we can also link here to our requirements table, which I'll do in a second. And also, we can also see from this activity, we can see how the work that we do inside this activity here is creating stakeholder requirements, which will then flow into our analyze stakeholder requirements activity in a moment. So let's come to this requirements table. Okay, it's empty as expected. So let's now import some requirements. I'm going to do this using textual notation. As you see here, so example, requirement, there's the ID, the name of the requirement of type stakeholder requirement. This requirement definition is done inside the Harmony library. And then here we can see the text of the requirement. So I'll click add, and there you go. There's our requirements imported. If I refresh the table, we get to see these requirements, each one in turn, for example, and here we can see the requirement definition. So all these are columns are defined inside our table, and we've got control over ordering and what we show. This is a good time to save the model, and what you'll see now is when we do the save, we now switch to a private branch. So we're now working in our own little area. This is also an interesting time to show the validate project. So let's validate our project. We see it at the bottom, I'll expand it. So model checks for CIC build for, which is our model here. And it's saying there's some language conventions. And here we go, usage names starting with uppercase. So it's convention that usages would start with a lowercase. So we can just, and you can see them here. So we'll just ask the tool to fix those. Okay, and I'll just refresh the table. And there we go. It's changed the case of those names. Okay, so that's now done. So we've now completed the collecting the stakeholder requirements. We've just analysed them as well, just checked them, and now what we can do is define our system context. So identify external actors and establish the system boundary and context. So let's do that. So we can go to our system context view. As you see currently it is empty. And so what I'll do now is actually, let's show you. So we could graphically build a system context. So let's just go back to our requirements. We can see here that we've got the system is basically going to be turning the interior light of the car on and off as doors are opened. But we've also got a requirement here around a temperature, maintain a temperature inside the vehicle. And so, okay, how would we do that? Well, maybe we're going to have a heater. So, like so. So we can add it. So we've got the ability to add elements using what I call the compass menu here, the plus. But we can also do it using textual notation. A part light, part door, and then connect our system. So it's called R under system, requirement system to light, and connect R underscore system to door, like so. I click add. Okay, so it's now added those elements. If we just want to have a quick look, say populate to a new view, let's choose the system context view, and off we go. So now we can see our door, our heater, and our light are connected to our system. On the door itself, we can also say, well, we've got 5 doors, not 56, 5. Click apply. Actually, I've done that wrong. Let's come back. Yeah, let's redo. Okay, showing you the undo and redo here. It's the cardinality I want, not the feature value. Right. So we want 5 doors. There we go, like so. And so we now have 5 doors connected to our system. Another thing we can do is let's make this a bit more meaningful. We'll call this our CIC at this layer. A few other things that we can do. So our door, heater and light are actors. So we could basically say, let me come back, here we go. Change type to a system actor for the door. I mean, heater, we could just do it this way as well. And the light, for example, too. And then what we'll do is move our door, heater and light up into the actors package, like so. Again, I'll do a save. And if we come back to, we're defining the system context. So I think we've now completed that. And it's saying identify use cases and their actor parameters. So we've got a matrix view that we could ultimately fill in, but use case view. So identify external actors and establish the system boundary. Okay, we've done that. So this is for our use case, identify use cases and their actor parameters. Okay, so let's go to the use case view, like so. We'll create a use case. So the use case really is around managing the interior light of the vehicle, like so. In SystemLV2, we will add actors to this use case, and we will also give it a subject as well. So the easiest way of giving it a subject is actually just to drag and drop our system part, and we'll connect to a new subject, like so. So effectively the tool has done this for us. And then our door and light, let's just drag them and drop them on here. Okay, bit of a jumble, but if we do a tree layout, there we go. So now we've got our light and door connected as actors to our use case and our system part. So this is the part that represents the CIC system, is the subject of the use case, and again it's bound as well. Okay, I'll click save again. So let's go back to the process view. Okay, I probably should have said we were starting to work on use cases, but I say that's now completed. What else do we have here? Requirements use case matrix. Okay, so we've got a matrix view now, and we've got our use case, manage interior light. So we can start to say, well, door detection, we're going to trace this requirement to the use case, for example. There's our trace, click add, and so on. There is also another matrix view, which is our actor to requirements matrix. So again, if we've got our light, we could say courtesy light on and off. We'll trace those also to our requirements. So we can start to create the digital thread of traceability between the various elements and the requirements. Coming back, so we've pretty much now done our requirements analysis. We're not going to do the MOEs here. So next thing, functional analysis. So here we're going to identify our system functions for CIC. We've got some automations we can run to effectively auto-populate this layer, but I'll do it out off the browser view. So let's go to our system context view now. So if I click on this element, you now see we're in the functional layer. So I'm just going to collapse the requirements a little bit. So we're now in the functional layer, like so, and I know that in order to auto-generate the elements in this layer, what I will do is I will run the Harmony automation on our use case up in the requirements analysis layer. So this makes sure that it then populates it to the layer below. So we'll say generate functional analysis artifacts. Okay. Again, just a reminder, I'll click on the view. So we are now in this F system context view. So we're in the functional context view for CIC. So we've gone down a layer. And you can see here, starting to look a bit more complicated. We can see our door of five of our doors is subsetting off door. So that colon greater than, a way of doing inheritance and traceability, but between usages, not definitions. And again, if we click on this, we can see our door. And if I click on door there, you see in the browser, this is the door in the functional package, subsets the door, which is up in the requirements analysis package. So we've created traceability here between the layers. You can also see now that we've got ports, and these are interfaces. So again, on the port, for example, we've now got a door port. So if I click on door port, you see this is a port definition, and ports are connected together using interfaces. So we have an interface between these two ports, and you can see here an example of a feature chain where you've got the dot notation. So it's actually explicitly saying, which instance of the elements are connected together. So let's go back to our process view. So we've done functional analysis, now derive functional system requirements. Okay, I will show this in the completed model, but I'm not going to do it here. Add system ports and interfaces. Okay, that's already been completed. So the next stage is add system functions per use case. So identify and organize system functions within the use case context. Fine. So let's start that. And all we can do here is go to this table. Okay, it's not so useful, but I can click here and find out where I am. So just above the use case view. So we're in functional, where you have this manage interior light. So again, the Harmony automation has populated this down to the layer below. And inside this, it's auto created an action flow. And if I click on the view, it's now currently empty. So now we need to define, using an action flow view, what manage interior light is going to do. And I've got a few ideas. So we're going to receive a door opened event, like so. We're going to also receive a door closed event, like so. And then you have, so this is an example of the textual notation below, accept payload via receivers. And what this really means is, so the payload is effectively going to be the event. And this is, I'll call it EV door opened. And then it's via. Now we need to reference the part that this item is going to be received into through the port. And so the item is our FCIC. Okay, the tool knows it. And then dot, and then we can say it's going to come in through the PDOR port. So now we've linked this action, well, accept action, to a part and a port, again using the feature chain idea. So we're like connecting our behavior and our structure together. And I'll just do the same again over here, except this is door closed. So this will be EV door closed via, again, I'm just going to use the keyboard like so. When the door's opened, let's say we just, I don't know, register reg door opened like so, and then we can also then go into merge node like so. On the other side, we have these different relationships or edges on an action flow. So I'm going to use a succession. It's a bit like a control flow in SysML v1. Okay, and then like, okay, look, I forgot to add the action in there. So I can just come here and drag and drop this action and just put it straight in here. So this is reg door closed, for example. Okay, so we'd start to do this. Let's just lay it out a bit more. And we'd continue building this action flow view. I think I've done enough to show the types of actions that you have and the edges to connect them together. And you've also seen some of the auto completion capabilities as well. So I think we keep moving through the demo. So let's come back to the started. So let's say we finished this, completed, okay. Next thing is populate ports. So define data items flowing through ports and create flow connections. The tool is able to analyze that action flow view that we've just done, and you can see that we've got certain items flowing now through our ports. And so what we can do is automatically populate ports. And what this will do is, I'll show you, I'll just click this automation. Let's go back to our system context view. So, and now we'll see these ports. Let's come back. This door port. Okay, so there's a door port. We've now got our items as parameters on the port definition. And furthermore, we could say, okay, on this automation, we could create flows as well. And come back. And now you see we've got a flow. So a flow on a connector set up. And again, you can start to see flow usage now between those two ports, those two parts, starting to show more information as to what's actually flowing across this type of connector. Back to process view. So we've done this. Okay. Next things around V&V. We're not going to do that. So let's now continue. Okay, create logical architecture artifacts. So now we're going to move down into the logical architecture layer. So here we will start to break our system into subparts, and then we will also start to allocate, using the performs capability, allocate some of those system functions, which are the actions, onto that architecture. So again, let's go to this view. So now we are down in our logical architecture layer. So I'm going to collapse. Let's collapse some of this. There you go. So we're here. I just need to open this back up again, of course, because I need to run our automation. So in functional, this there's our use case. This little icon helps me because it shows it's not complete. I'll say harmony, generate logical architecture. And there you go. So it's the same pattern as before. Let's come back to our process view. Okay, that's done. Now derive subsystem requirements. I'm not going to do that. Add subsystem parts. Okay, let's start to work on this. And again, we can just jump back here. I'm just going to briefly show some of this. I just need to make myself a bit of room. We'll switch on the graphical compartment, like so. And then what we can do is start to add parts into. So this will be something like the door manager part, for example. And this part will be responsible for keeping track of which doors are opened and closed and stuff like that. So I can just sort of make myself a little bit more space in here. And, you know, as an example now, let's choose the right interface. Now I can now effectively come down and continue. Door events are now going to flow into our door manager part, for example. Again, I'm not going to go any further with the demo with this. I just want to show you now how we can allocate functional behavior onto that door manager part. So I'll come back up to our behavior view. So again, Harmony's copied this action flow view down into logical. So we did it originally in functional, it's now into logical. So our main behavior view. The thing that I'll now use is a swim lane. And so if I drag and drop the swim lane over this, let's just make it a bit more easy to see. And you see it says currently not allocated. And so what I will do is our door manager. So at the moment our door manager part we just created just got a porter in it. I'll just drag and drop this onto the swim lane. And now you can see our door manager performs door closed and also register door closed as well, performs those two actions. Okay, I will save the model. And I think that's a good place now to switch to the completed model. Okay, so I've gone back to my project view, and here we have a completed CIC model. So let's open this, and I'll just show you a few other things that we didn't really cover in the first part of the demo. So first of all, we have the all view summary. So this shows us all of the different views that are currently within the model. And so this is a nice sort of jumping board to be able to see or go to a specific view in the model, particularly if we don't really know where to find it. You know, for example, we've got some deeply nested action flow diagrams here around the behavior. So we could just come and jump here. So this is for our control lights, for example, where we were before. And this is the completed action flow view for those lights. So let's just go back up to the top again in terms of the model. System context, I think we completed most of this, apart from we didn't have the driver actor. So we've got this now. We've now also got a completed actor matrix and also the use cases. So we've also, in this model, it's got the control temperature use case as well, which we had a requirement for. Moving down into functional analysis, again, we've now got the control lights use case fleshed out, and also the control temperature. So we haven't seen this before. Let's have a look at this. So this is around controlling the temperature inside the vehicle. Again, you've got a request favorite temperature event that's coming in from the driver. This model also has some system requirements defined in the functional analysis package. And let's have a look. So here we've got a requirements diagram where we've got two system requirements, and we've added some constraints. So each one's got a constraint inside it about the doors being closed or open, and also it has some required constraints as well. So this assumed constraint, all doors closed. So that's this one here. We're showing it graphically as well as in the compartment. And then we have a requirements coverage table, again around these system requirements. So there's the actual description of the requirements, and we can see that these requirements are satisfying, and these are actions on our action flow. So we could find them, for example, where we just were in terms of the main behavior diagram. Moving on down, we now have a completed system context. Again, you've seen we did some of the work before. You've got door handling, so this is now further details in. So we've got 4 internal parts now for our model. Now, for example, door handling, we could say, well, we don't actually want to see those compartments, so let's turn them off. And we could also maybe say, well, we want to give this a particular color, for example, and apply that. And so we've got a lot of control on the layout of the diagrams as well. In terms of the use cases, so we'll now see, let's go to control lights, the swim lanes fully defined. So here we go. So now we've got door handling performing these accepts and actions, and light control part performing these. And again, if I click on the top here to light control, we'll see that reflected here in terms of the performs. And then finally, the layer that I didn't really go into, the physical layer. So here we define a physical breakdown of our system. So again, we've got our system actors on the outside, but now our CIC physical, it's got a body controller and an instrument cluster, and then body controller's got some software inside it, body controller software, etc., sensors. So we're effectively creating a hierarchical view of our physical, and then we can start to create mappings. So we can say, well, these logical parts like door handling, these are going to be mapped onto the software, body controller software, physical part, for example, and so on. So I think with that, thank you for watching, and that concludes the Rhapsody Systems Engineering demo.